Alright, so now we're going to go into part B of this lab, which is electrolytes and conductivity. What we're going to do is we're going to find out which of these samples are electrolytes and which of them are non-electrolytes. And among the electrolytes, we're going to find out which ones are weak electrolytes or strong electrolytes. To do this, we need a spot plate. This is a spot plate. It's not cleaned yet, so if something you just picked up from the lab, never assume it's clean. So what we're going to do is we're going to come over to the sink and clean it really good, right? The reason that we're cleaning this really good is because a lot of chemicals in the lab, they're colorless, and we don't know if it's still contaminated. And if we still have samples on it, it might affect the results. So we can even use some soap. Yeah, soap. We can use some soap to clean it up really good. Yeah. And rinse it off. Right, now we got the soap off. The question is this clean yet? Yes or no? It is not clean yet, since I'm asking you this way. It is not clean because we clean it with tap water. And inside tap water, there might be hard water ions inside, there might be magnesium, calcium inside, and those ions can affect the results of this lab as well. So we're going to use this thing called deionized water, DI water, which is doubly purified water, either by distillation or reverse osmosis, to make sure that this water has none of those ions inside, and it's just water. So it's pretty much the purest water you can get inside a lab. I'm going to rinse this spot plate down really good to take away the dirty tap water. We're going to use the cleanest water we have in lab, okay, like this. Practically, the spot plate is clean, although it's still wet, but there are none of those ions that can mess with your results. So practically this is clean. If you don't like this, you can wipe it up with a paper towel or a CHEM wipe. For us, we can just walk over back to our setup. Use a paper towel. And on your labs, you probably realize that there are 7 samples that you need to test. This spot plate happens to have 12 wells over here. And if you just start putting samples onto the spot plate, you might lose track. So really importantly, like we probably have mentioned earlier in lab, we want to make sure that we label everything. So here happens to be a labeled sheet, very conveniently sitting here, that has all the samples that we're going to be doing today. So we're going to load everything up with these samples indicated. First of all, we're going to use isopropyl alcohol. So let's get some isopropyl alcohol. Can't see. This one. I'm going to fill up the well plate with isopropyl alcohol. First one. Make sure we don't cross-contaminate. What's the second one? Read your lab manual. It's 0.1 molar HCl. It's hydrochloric acid. It's an acid. We'll make sure you don't get it on your skin. Let's go ahead and fill this well plate up. As you can see, it's also colorless. The next sample is NaOH, sodium hydroxide. Also at the same concentration, 0.1. So let's load this plate up too. All right. Oh, I think I spilled some. It's not good. Okay. Let's go ahead and skip the CaCl2 because I accidentally spilled some NaOH inside, and that's definitely not going to be very desired. Let's go ahead and go to this still clean well plate, which is acetic acid. Over here. This is a great lab simulation. People always make mistakes here. Okay, so let's make sure the tip doesn't touch the well. Okay, careful. Next up, we have isotonic saline. Let's load this one up. And then isotonic glucose. Did I get this right? No, this is isotonic glucose. I accidentally switched it. So there's so many errors here. I think this simulates an actual lab very well. But this is isotonic saline. So what we're going to do is we're going to switch this up, right? That's the fun part of this lab, that you get to mess up and get to try again. Unfortunately, you're all learning this online, so you don't get to do this. I get to do this. So we're going to make sure that this is fixed, saying that no, this is no longer isotonic glucose. This well plate is isotonic saline. This one is isotonic glucose. So we're going to switch these two around. And then this calcium chloride got messed up. So let's use this well plate instead, 0.1 molar calcium chloride. All right, so let's use that well plate to hold our calcium chloride. Place it here carefully. All right. So now all the well plates are loaded. Next up, we're going to use this conductivity device to find out which ones conduct electricity. If things conduct electricity, the light bulbs will go up. They're going to shine very brightly. If the substance that you're testing does not conduct electricity, it's going to stay dim, not even dim. It's not even going to go off. So basically, you can differentiate between electrolytes and non-electrolytes through this device. And then, depending on how bright the light bulb goes, you can determine if it is a strong electrolyte, where the light bulb just goes off very strongly, or if it's a weak electrolyte. So let me just show you really quickly if something was a great conductor, what it's going to look like. So I have something metally here, all right? And metals conduct electricity. So once I make the two electrodes touch, you see it going off? You see that? This is as bright as it can be, okay? I'm going to let go. It turned off again. Now on, right? This is as bright as it gets. So if you see such a bright light where green and red lights both go off, that's a strong conductor. That's a good conductor. That's going to be a strong electrolyte. On the other hand, I have some deionized water here, all right? And in deionized water, there are no ions to conduct electricity. So what would you expect? This is deionized water. There's no ions, no charged particles there. Let's take a look. Let's dip the electrodes in. What do you see? Let's take it out again. Let's dip it in again. Let's take it out. Are you seeing what I'm seeing? Yeah, there's nothing happening. So for DI water, there's no ions, and it's a non-electrolyte, right? Try to say that, non-electrolyte. There we go, all right? So what we're gonna find out is all these 7 samples over here, which ones are electrolytes that make the light bulb go off, and which ones are not electrolytes that don't make the light bulb go off. And then, depending on how bright or dim these substances allow the light bulbs to shine, we can categorize those electrolytes into strong electrolytes or weak electrolytes. All right? And be aware that between each sample, because we don't want to cross-contaminate everything, each time we test a sample, we need to take it out and rinse it again really well with DI water. And that's why we have this DI water bottle over here. Okay, let's get started. I'm going to stop talking. I'm going to let you make the observations here and write down all the observations in your lab manual. Let's begin. First, isopropyl alcohol. Let's take a look. All right, I dipped it in right now. Give you 5 more seconds. Make your observations. What do you see? All right, taking it out. Now I'm going to rinse it with DI water. Make sure it's clean. All right. Next up, we're going to take a look at 0.1 molar HCl. Okay, I'm going to dip it in now. What do you see? Give you 5 seconds. Take a look. All right, I'm going to take it out. All right, now I'm going to rinse it in DI water again. rid of the HCl. All right, next up, let's take a look at the 0.1 molar sodium hydroxide. You guys ready? All right, let's dip it in now. What do you see? What do you see? Okay, let's take it out. All right, so make your observations, write it down into the chart on one of the pages. Clean it up with DI water. And let's move on to the next item on the chart, which is actually calcium chloride, okay? Calcium chloride, okay? I'm gonna dip it in right now. Go. What do you see? Okay. 2 more seconds. Make your observations, note it down. All right, take it out. All right, that was calcium chloride. Let's clean the probe up really good. And now, the next one is acetic acid. Let's find out what acetic acid looks like. Again, observe the bulbs. All right, dip it in now. Okay, what do you see? Okay, just write down what you see. I'm not gonna make any comments. You make the decision. It's your lab. All right, let me take it out now. 3, 2, 1. All right, that was acetic acid. I'm gonna clean the probe again. Now let's dip it in to the next one, which originally on the chart is isotonic saline, right? Take a look at the light bulbs. 1, 2, 3. All right, what do you see? 5 more seconds. 2, 1. All right, so take it out now. That was isotonic saline. Let me clean it up really nicely with DI water. Lastly, we have isotonic glucose. All right, 3, 2, 1. What do you see? Okay, I'm gonna take it off in 3, 2, 1. All right, there you have it. All the data should be collected by now, and this is part B. Your lab instructor will explain how to use a chemical equation to describe strong electrolytes, weak electrolytes, and non-electrolytes. So good luck.